Hello, everyone. Welcome to Mining Now, filmed from Mine Expo. Today we have Austin Powder on the show. We have two guests. I actually need them to help me set up who's with who here. So we got Al Romphf. You're the Global Blasting Engineer Manager at Austin Powder.
That's correct.
Okay, so I got that part right. Then Cameron McKenzie, you're the Blast Expert Developer. No, you said to correct that. You're the founder of Paradigm, a Blast Expert. I got some help. What's the setup here?
Well, let's use that word expert.
Yeah, let's go with expert. Yeah. Okay, we'll use that sparingly.
Yeah,
what's your background? Let's start with your background.
My background here is as a consultant.
Okay.
I'm Australian, and I work around the world in the mining industry, quarrying industry. And about 30 years, a little more than 30 years ago, I met up with some people in Austin, and we've been working together ever since.
Okay. That's a good setup. And now Austin Powder.
Sure.
Let's give some context for anybody who doesn't know who the company is.
So the company, it's an explosives manufacturer, first and foremost. It's been around for a very long time. You can see from the logo, it's been around since 1833. Began as a black powder manufacturer, and now we manufacture all things explosives and blasting related. So we also, not only do we make the explosives, but we use them professionally in mines.
Okay. Okay. So you're not just delivering; you're actually on site doing the blasting.
That's correct. Yes.
Oh, okay.
We do both. We can deliver to mines that have their own personnel for blasting, or we do that as a service as well.
How long has it been delivering those services at a whole? Like when it first started, was it just selling the powder, or has it always been the sort of that explosives?
Well, during my career,
1833. I mean, that's a ways.
During my 22-year career, it's been both blasting service and manufacturer, of course. Originally, though, as a manufacturer for black powder for rifles and sporting, and as well as mining.
I was just at a fort. We're both Canadian,
right.
But I was at a fort over in Western Canada, and they were shooting one of those old muskets. And this is one of these facts that nobody cares about, other than the people that do. The broadside of a barn thing is a real thing because those muskets were so inaccurate. Yeah. Once it overheated, it literally couldn't hit a broadside of a barn.
Okay.
So there's my good story for the day. Sorry about that to people that had to live through that.
Now, what about blasting made you think of that? I'm rather hoping that we are a little more precise.
Tamping the black powder into the
little
musket,
thing, the black powder. Yeah, exactly.
Yeah.
Main areas of use is something I wanted to cover because again, it's so easy to sort of assume people watching, but 30, 40,000 people watching an episode. What are the different areas where it's applicable?
So explosives are used in large-scale mines, quarries, construction projects, used for demolition. But most of the consumption of explosives is in mining, so where we need to break rock to process it further. So we take a bunch of solid rock, load it with explosives, blow it up, and then it's processed further by the mine for aggregates or to extract the metal out of it, whatever they're looking to gain from that material.
What is the fly rock model? I saw that in a note. What is that? What is that referring to?
Oh, so a fly rock is if a rock is thrown further than expected, or it's striking something beyond where you intend to throw rock from the blast. So the fly rock model is a tool that we use in our Paradigm software that will predict the extent to which rock could fly, and also the probability of striking something within a zone. So it's used to determine how far away do you need to be from the blast. So
and that's within. Okay, well let's jump into Paradigm then. What is that platform for anybody who doesn't know? Maybe I'll let both of you sort of explain it. Maybe its origin. Maybe start with you with the origin, and then build into where it is now.
The origin came about because of the need for a blaster to be able to be quite confident about the outcomes. And there can be a lot of different outcomes when you press that button. A lot of things happen very quickly and very violently. And we have to make sure that we contain that violence and direct it onto the rock rather than onto the environment.
Right.
If you don't get that right, then you do have quite large fragments of rock being thrown rather large distances, like a kilometre. And even a mile.
Wow.
It can throw rock that far.
Wow.
And rock that goes that far will kill if you happen to be in its path. So that's that's kind of the worst case outcome, and that one gets a lot of attention because it is the worst case. But then also when you push that button, you like to know that everything that happens is under control. We don't get rocks the size of Volkswagens, we get rocks that are the size of a lunchbox, for example. That's what we're trying to achieve. And we only want to break the rock in front of the blast holes. We don't want to break the rock behind it because that's going to form the walls of the pit, and we're going to be working down the bottom of that pit. It's really nice when the walls stay up and don't follow you all the way down to the bottom. So it's all about being able to control the outcomes. And so mathematical modeling is all about understanding the mechanics associated with these outcomes, and then applying the principles of physics and mathematics to say, well, if I know the inputs, how much explosive and energy and all that, then I can estimate the outputs. So that's why the program started to develop, so that we could put a tool in the hands of the blasters so that they would feel confident when they push that button that what's going to happen is all in control.
I have to ask, it's one of these technologies you go, well, of course, you'd want that on the blast site. How was it done before? How did you just, what was
the trial and error method?
Well, a little ahead of the musket time. We'll jump somewhere in between those.
No, that's a really good question,
So the engineering term is an iterative process, but it's trial and error. So
I love how they came up with a term for it. Of course.
So, but the beauty about designing a blast in software is you can iterate before actually drilling a hole in the ground and try to determine, hey, if we change something about the process, how does that change the results? Be it ground vibration or fly rock potential, damage to the high wall. How would a change in a parameter of the blast affect the outcome? And so rather than just saying, hey, we're going to try this, we can simulate it and see, does this make sense to try this from a cost perspective and from just a practicality perspective as well.
So really the previous way was see what happens. Get back.
Well, one of Al's favorite comments is that, is blasting an art or is it a science? And I think really what we're saying is that it's a transitional. We're moving more and more closely to the science.
Yeah, I don't think it's an art. It's a science that's not yet completely understood,
right.
And we're working to produce tools to help people in this field better understand what they're doing.
So just really basic, where is that data coming from? That paradigm, how are you extracting that information? Is there sensors that you're putting in the rock? Is it data that they've gotten from like core samples? How are you gathering to determine?
Well, that's part of what I call this transition. And if you go back 50 years, I think blasting probably was much more of an art. And a blaster who could do his job really well was really highly valued. We're at the point now where we blast so often. We need so much aggregate to make our roads and our concrete for the buildings and all of that. There's so much more blasting, and we don't have those really expert blasters anymore. So we need to be able to train up ordinary people, train them up with the best science that we can, and we utilize things like drones to take beautiful photography so that we get a very clear image of what it is we're blasting.
So you're doing like basically topography mapping.
Correct. You know, we get beautiful topographical models. And so you can sit in a room now and it looks like you're on the bench.
Right.
You can see all the rocks and all the irregularities.
Yeah, but we populate that model with other properties taken from sensors, taken from drills, taken from vibration sensors. So we're striving to replicate the conditions that we realize in the field. And
so I'll throw out a buzzword then. So how close is this a digital twin, or is it a data set that someone's looking at? Where does it sort of land in that sphere?
Effectively, we are building digital twins. when we build a terrain model and we assign properties to that model based on data extracted from equipment. So yeah, we've been doing that for quite some time with the software. That's become a term that's being used a lot in the industry's digital twin, but it's nothing new to us other than the term.
So does it? Okay, so I'll try to not butcher this question and make sense of it. There is in safety. I had a really interesting interview, and someone was saying that the goal, you want to eliminate fatalities, of course, that should not even be on the table. That should be eliminated. Then you have these essentially different tiers of injury. And there are scenarios where if you, he put it so much better than I'm going to, but essentially, if you try so hard to eliminate all these little tiny risks, you end up actually sometimes setting up for major. There's scenarios where it can actually cause more risk because you're basically nitpicking everything so much that the people make these major errors. Very butchered version of it. What I'm getting to is things like fly rock. When you're doing a digital twin, for lack of a better word, you're doing a digital twin, do you have to account, it's not going to be this perfect thing that goes poof and there's a little puff of dust. It's still going to be an explosion at the end of the day. So are you making, or is that
Not
wrong?
necessarily, no. To me, a perfect blast for a quarry, for example, the only movement you see is the rock basically falling down. So you get zero rocks ejected.
Really?
Zero.
So that is a goal?
Sure. Well,
oh, wow.
The rock certainly moves.
Right, yeah.
No,
but in a controlled fashion.
Because when we've got rocks being ejected, we've got energy that's now being released to the atmosphere. And that has other impacts as well. Overpressure. Okay, it makes a loud noise. And it's not just noise. You can't even hear all of it, but you feel it as a concussion on your body, and it shakes windows and it shakes houses, and people complain. So we have to eliminate that as well. Now, in a mining environment, sometimes we go the other way and we say, look, I've got hard rock right on the top. I'm going to have to put energy very close to or in that hard rock. And so, therefore, we do get quite energetic ejections of material. But in that case, we have to know, well, how far can the rock be thrown?
Yeah.
Because that's how far we have to move equipment and people.
Yeah, that's exactly what I was getting at. So you have an understanding of what it's not about, in that case, it's not about complete elimination.
Correct.
It's about understanding what it's going
Control.
to result.
And so we'll include a factor of safety with this, and that comes down to the certainty of how accurate is the information you're putting into the model. And so if you're certain that the blast is loaded as designed, then your factor of safety might be a certain value. And if you're uncertain, then that factor of safety needs to increase.
Right.
Right.
And so in these programs now, what is let's say, how long has Paradigm been around? How long has it been online being used?
Well, now there's an interesting question. I suppose about 5 years.
5 years.
People have been buying licenses.
Okay.
Yeah.
So, and I guess I should clarify, is the people buying licenses, that's not just Austin using it, that's
correct.
Like third-party blasting companies.
Austin and strategic partners
are using it.
Have access to Paradigm, yeah.
Okay. So when they're using this platform, how much from 5 years ago to now does it look the same, like visually, if you're looking at the screen? How much has it evolved?
Oh, significantly. We're continually developing it. We have a task board of hundreds of additions that are on deck to be added to Paradigm. So there's been huge gains since over the last 5 years.
Yeah.
Look, no sooner than you've delivered something that somebody asked for, the goalposts move, right? And,
yeah, exactly.
Well, that's great, but could we have this as well? And an example of that, for example, is when engineers come to look at Paradigm. It was originally developed for quarries and open and surface mining.
Right, yeah.
Well, inevitably, an underground miner is going to come along and say, well, why can't I have something that does that? And so we said, well, that's a good question. What can we do in the underground? And so we now find that it's developing to handle applications in the underground as well as the surface. And that's just the nature of software. It's like a coral reef.
Yeah.
It starts off small and then It just keeps growing. As
Right.
long as you keep feeding it, it keeps growing.
Well, that's a whole other topic about keeping it fed these days. But what about like usability? Like you mentioned, making it so essentially more people that aren't. There's someone that had 40 years of experience. Well, some of those people aren't around now, and you've got a younger workforce coming in. I've had all kinds of conversations about people trying to attract people at every discipline in mining. It's a real challenge.
Yeah.
What about usability? How has that evolved? Where is it at now?
Well, it's an engineering tool, so it's not designed to be the easiest tool. However, it's quite accessible. It's laid out in the ribbon type format that people familiar with Microsoft type applications would have, like Excel or Word.
Yeah.
And so people are pretty familiar with the interface, people that are generally computer literate.
Yep.
But it is a CAD-like program where you need to be careful about what you do in it. But I think the learning curve isn't that steep for someone that's pretty well versed in blasting and can use a computer.
What are your thoughts?
Well, what I was going to say there is that while a lot of the modeling may have been developed by quite grey-haired people, the user interface, which is really what you're referring to now, is how easily can the outputs and that be created by the user. That user interface is all developed by young people, and they know how they want to get access to information and how to process that information. So on the developing team, for example, we've got 3 generations of people there. I've got a grandson, I've got my son, and then there's me, and the younger people there are fantastic at bringing new ideas, and that old people like me have got no way to understand, but they know how young users need to be presented with information and make it easy for them to process that information. Then they do a first-class job of that.
Yeah, there's no point in having these fancy models if people will not be able to use them.
Yeah.
So it's really important to make it accessible so that they're actually useful to the people that need them.
Just circling back to that sort of that 5-year period where it's been in the market, people have been buying those licenses. How much of the evolution? What are a couple standout developments over those last 5 years that you go that it's really made it a just that much better of a product?
I think the environmental effects models are one of the most popular things that people use to model vibration both near and far field.
When did that come online?
Well, it's evolved.
I see.
Okay.
Okay.
It's one of the original features, but it's just progressed to be able to perform more simulations, more complex blasts over the course of the while the software has been developed. What do you think about the?
Well, I think the addition of the underground, the application to the underground environment.
So is that underway or is that implemented now? That's offered.
It's hard to actually tell what is the underground part of it and what is relevant only to surface.
Right.
Because when you want to predict the fragmentation, the common thing is a hole with explosives and rock. Well, that can be the underground or it can be the surface. And it's the realization that really it's the same environment,
right? But
it's just got a different access and a different distribution of the explosive through the rock. So it's not really all that different at all.
Yeah.
But where we're going now is cloud type applications and being able to get data from all those machines that you see over there.
Yeah.
Have those machines talking to Paradigm, and Paradigm knowing before the designer even wants to create his blast. We already know. We've already got data about that. We already know what you should be doing, and that's the exciting part. I think that it's no longer just a little box drawn around the blast pattern.
Yeah.
It's out there looking for data from all sorts of places.
How long have you been with the company?
22 years.
Okay, sorry, you said it, 22 years. Okay, so in that time, I'm curious for both of you. This is a question I asked. I pick who I'm going to ask this question to because I get some pretty interesting answers. What have you seen in the industry when it comes to the demand? So give a scenario. 50 years ago, you walked on with this tablet. No one would know what it was, how it was, worked. They wouldn't even know how to turn it on or get in. Now, everybody walking around here pretty much has a smartphone, and they're pretty handy, pretty much at all ages now. Mm-hmm. So that technology adoption and demand, now people want it. It's sort of shifted from companies maybe trying to get it to the market. Now people are asking for it. Have you noticed that shift in your company? Like now something like a Paradigm is almost demanded. It's not really you trying to put it into the market.
It's an expectation.
Yeah.
Mines are more and more high tech, and from their explosive supplier, they do expect a good software package to model and design their blasts.
Yeah.
And we think we provide a very good one for that.
Was it like that, but 10 years ago, was it like that? Or would it almost be like you'd have to try to sell them on this thing? Or not really?
It's not a hard sell. What happens is you show a few blasters, and especially the young ones are just drawn to it like a moth to light.
Right.
You know, they're crying out for the young. The difference between the younger blasters and maybe the older ones is that the younger ones are looking for more of this modern connection via electronics, via a tablet, via your phone. They don't even really want it on a computer. They want it down to something smaller.
Yeah, computer's
and
not
more
good enough
mobile.
anymore.
No, it's got to be something smaller than that. And the young people are drawn to that. That's just how they think these days, that if they've got a problem, they go to your phone. And ultimately that's where we'd like all of this to go, to have access to this sort of technology, make it as easy and as interesting and as fun and as enticing as we possibly can.
And there's a demand. The demand is driving that.
There's an expectation, absolutely.
Yeah, that's an interesting way of putting it. It's an expectation. It's
well,
not,
the expectation is
demand. Expectation is a better word.
Yeah, and it's on both sides. I mean, the clients see it and want it. See, we like the look of that technology. We want you to have it. The blasters want it because it makes them feel great and confident that they really understand and got everything in control. Because what you need to understand is when that guy pushes that button, he's at risk.
Yeah.
Anything goes wrong, the guy who pushes the button, it's his problem.
Right.
Okay. So he needs every bit of assistance he can possibly get to feel confident that everything's going to work out when he pushes that button.
Yep. Before we wrap up, I'll ask both of you. Most interesting or standout question that you've gotten at this event? Start with you, sir.
How the heck did it happen? I mean, you try to describe an event. This is my first time here. Okay?
Oh, it is? Okay,
I've known about it for many years. My first time here. And I still believe this is in the impossible basket. I don't know. This is smoke and mirrors. It's got to be a Photoshop job. So.
Well, it is Vegas. You might go tap on one of those machines and it might be hollow.
They're real. I did that. They're real.
Okay.
And, big is such a small word.
Yeah.
And it just doesn't come anywhere close.
I know. I tried to describe it,
like
but people can't until you go, and then you see people walking. People that don't even know. People will come with their partners or whatever, and you can see there's a
it's
sort of
not just the size of the machinery, it's the diversity in the services
and the beauty of some of these designs. You look at you can see this is pristine design, and the countries from all over the world are representing their engineering capabilities. It's quite beautiful
engineering.
Yeah. What about you? What's an interesting, maybe through the booth coming through, what's an interesting question you've gotten?
I love giving demos of our detonator technology, our Paradigm software. So I've had opportunities to give people one-on-one demos and let them take it for a test drive, show them how it interacts with the electronic dets, and just we can design a blast, like a simple blast in seconds, and often people will see a demo and say, wow, this is really great.
Wow.
And it's great to,
just be on
go
the floor,
through that process
and a lot of interest
with potential customers and current customers.
Yeah, are you getting a lot of interest just right here on the floor?
Oh, absolutely.
Yeah.
We've got a lot of, a great looking booth with lots of interesting graphics, and people think, hey, what is that? How can I use that at my operation?
Yep.
So
it's a great setup you have, and you're in this is a great hall to be in. You're in a great spot.
Sure.
So
you look at things like that and over there, and you think the technology inside that.
Yeah.
How did it develop? how did it get to that stage of beauty and engineering?
Well, they've got one of the
excellence?
original dozers. Did you see that?
I
Over
did.
that's
Yeah.
the neat thing.
Yeah.
It's one of the.
Yeah.
I don't know if it's the first, but it
Yeah.
might be their first production model or something like that.
Yeah.
Pretty neat. And I mean, blasting. How we've done multiple blasting episodes and seeing how far that industry has come, and it's something I think it's important to talk. It's easy to you see the big things, right? But mining also comes down to these little sensors, little technology, little data points that make a big difference. And blasting's a pretty good example of that. So,
Sure.
gentlemen, thank you very much for doing this episode. You were razzing us a bit to start. I hope it wasn't as bad as you thought it might be.
Our pleasure.
Yeah, no, it was great to have you on. Thank you both.
Thank you.
Thank you, sir.
Thanks you.
And thank you, everybody, for watching. Please go check out Austin Powder on their website. This will be getting released after you, so you won't be able to come check out their booth. But go check them out. Follow them on LinkedIn. Connect with these gentlemen on LinkedIn. Are you both on LinkedIn? I think I saw.
Yes.
You are. I saw there was no link for you, and I couldn't find you. So I'm going to assume you're not. If he is, though, we will add him in the link in. Thank you, everybody, for watching. Make sure to subscribe to our channel as well, and we will see you on the next episode of Mining Now.